Hey everybody, Dr. D here. Decided to make this video on a little bit of working with the metric system. You're not required to do a bunch of memorization on the metric system. I'll never ask you any questions on like the quizzes about the metric system. You'll always have the ability to look something up. But I do think it's important that you're somewhat familiar with it. I gave an example online is that water quality reports are often reported in these types of units. But true story, when my daughter was really young, soon after she was born, she had a minor surgery, and she had to take some sort of medicines before Google was around. My wife comes up to me, and we're at home, so I don't have any of my chemistry textbooks or anything like that. She said, well, how much do we give our daughter? How much do we give Claudia? And the bottle said, give your child this many milligrams per kilogram of their body weight. And it was a liquid, and there were so many milligrams in each liquid. So first we had to figure out, hey, what's her body weight in kilograms? So I had to convert from pounds to kilograms. And then I had to figure out how many milligrams she gets. And then I had to figure out, okay, how many milligrams per mil, and figure out how many mils she got. And because I know a conversion between each of the three systems, that's one for mass, one for volume, and one for distance between the English system and the metric system, I can do any conversion anytime, anywhere, without any resources. So I just want you to be a little bit more comfortable with it, a little bit more familiar with it. So next time you pick up a bottle and look at both the volume in gallons and liters, and realize, and most of you know this already, probably from buying liters of soda, that liters roughly a quart. So these types of things become useful. And as I mentioned, water quality reports and things like that are based on the metric system. And 98% of countries in the world use the metric system. It's a far superior system. Once you learn it, it's all base 10. You don't have to remember things like 5,280 feet in a mile. So it's a much superior system. If you travel abroad, then you be more comfortable when you see things and you're trying to buy stuff. So I'm going to share my screen with you here, and we're going to go over a little bit of metric system here. And this is just going to basically show you the slides that we actually just looked at. And here's what I'm looking at here. Okay. Now, I always tell my students, even my science courses, arrange your metric system in a list like this. And what we have at the top, is kilo. And then we have the base unit. What I mean by base unit, that could be grams, mass without any prefix, grams, volume without any prefix, liters, or distance without any prefix, meters. Okay. And then you have the common ones here, centi, milli, micro, big ones. And you've heard of nano too. And what the symbol means, I give you the multiplier and I give you the exponential notation. Those are the same, just two ways of looking at it, of course. If you include the zero in front of the decimal point, then the exponent is basically the number of zeros. 1, 2, 3, and 10 to the minus 3. Now, where people get confused, they see the multiplier is, well, let's just take centi, 0.01. And they say, oh, okay. So if I have 1 meter, that means I have 0.01 centimeters. No. It means if you have 1 centimeter, and I'm going to use this right here, 1 centimeter equals 0.01 meters, not the reverse. And the way you remember that is the centi means 0.01, so they need to be on opposite sides of the equation. So that's basically saying that 0.01 meters equals 0.01 meters. That's kind of what you're doing. If you put the centi and the 0.1 on the same side, that's where people get messed up. And even some of my science students do that. So what I want people to realize then is that, and I say this on the next slide, whoops, that's not what I wanted to do. Let's undo that. If I say this on the next slide, I was trying to scale up move my slide, but I'm on the pen. So how do I do that? Get rid of that. Okay, so next slide, moving up or down, moving up and moving down, you see? That's what we want to focus on. So if I want to go from micro to centi, I would say 10 to the 6 and 10 to the 2. The difference is 10 to the 4. 10 to the 3, this is 1,000, so that's 10,000. Difference of 10,000. But when I move up, I divide by 10 to the 4. Okay. If I move down, I multiply. You're going to multiply by 10 to the 4. That is no different than, again, that is no different than listing dollar, dime, and penny. Notice I've done the same thing. A dime is 0.01 based on the base unit of a dollar. A penny is 0.01. It's just like centi. It's down below it. So if I go from 1 penny to a dollar, I wind up with $0.01. I divide by 100. Okay. If I go from dollar to penny, I multiply by 100. So that's the key here. And getting familiar with that. And that applies to any of these units. So it doesn't matter. So you just got to pay attention to the exponents. It gets a little tricky when you move across this right here from 10 to the third to 10 to 2. But it's still a difference of 5. And that's all you have to worry about. Don't worry about the negative and positive exponents, because I'm doing it as dividing and multiplying. That solves that problem. You don't have to worry about it. So just look at the difference in the exponents. Do account that as 5 and not 1. That's where you got to consider the negative. -2 to 0 and the 0 to 3. But that's its places of 5. So that'd be, 10 to the 5th. You divide or multiply by, depending on which direction you're going in. The difference with ppm and ppb, and I'm actually going to erase this now because I want to look at this here so you can see it. That was okay there. This was 1 centimeter. I'm going to leave that there. Okay, now, ppm is milligrams per liter. That's supposed to be a milli, sorry. And ppb is micrograms per liter. So they're concentrations. That's difference. Amount of material in some other amount. So it will do it in terms of liquid, in terms of volume. So amount of substance in a particular volume. So milli and micro are right here. They are 1,000 apart, 10 to the 3. So because ppb is micro and ppm is milli, if I'm going from pp, let's do it the other way. I think we did it multiplying that way. Let's undo that to keep it consistent, at least with the previous part of my slide. If I'm going in this direction, I'm going to multiply by 1,000. If I'm going in this direction, divide by 1,000. It's the same thing. It's only, I explained in the lab how how ppm and ppb come about to be milligram and micro per liter. So that's just to explain to you what it means. But it basically means 1 in a million and 1 in a billion. And I started out with mass on the slide. You could start out with volume 2, but then it gets a little bit trickier, so I chose the easiest route. But that's all I really want you to know, is to understand the magnitude of difference. So when you see a water quality report, they're talking about, chemicals in your water, and they're talking about parts per million and parts per billion. You have a sense of what that means in terms of the amount of substance in your water. So hopefully this will help you with your lab. With that, I guess I can stop the video. There's my screen share stopped, and that's it. So good luck with the lab.